we know that fugacity and pressure become equal in the case of ideal gases, whereas in the case of real gases both are different. Now we are going to discuss the determination of fugacity by graphical method. We have this equation dg is equal to vdp minus sdt for an isothermal process. Dg is equal to vdp. That is equation number 1. And we have dg is equal to RT d ln f. This is equation number 2. By definition, dg is equal to RT d ln f. So if we compare equation 1 and 2, we can write like this: RT into d ln f, and that is equal to vdp. That is equation number 3. We know that for a real gas, PV is equal to RT, or V is equal to RT by P. That is, the molar volume V is equal to RT by P. And this is true in the case of ideal gas. And in the case of real gases, V, that is the molar volume, and that is not equal to RT by P. That is not equal to RT by P. So we can write like this: V is equal to, what is V? V is equal to RT by P minus alpha. And here alpha is a new function, and it is a function of temperature and pressure. So namakkariyam real gas in the case the molar volume V cannot be equal to RT by P. അപ്പോൾ അതിനെ equal ആക്കാൻ വേണ്ടി we introduce a new function called alpha, new term called alpha, which is a function of temperature and pressure. Okay. Now this is equation number 4, and now we have to substitute the value of V, or equation 4, in equation 3. So we can write like this: RT d ln f is equal to RT by P into dP minus alpha into dP. Okay. Or we can write like this: RT d ln f is equal to RT d ln P minus alpha into dP. Or if we divide this equation throughout by RT, then d ln f is equal to d ln P minus alpha by RT into dP. Okay. Or d ln f minus d ln P, that is equal to minus alpha by RT into dP. Or we can say that on integration, before integration we can write like this: d ln f by P, and that is equal to minus alpha by RT into dP. or on integration ln f by p, that is equal to minus 1 by rt into integral alpha into dp, or ln f minus ln p is equal to minus 1 by rt into integral minus alpha, sorry, not minus alpha, alpha into dp, right? So, and this is equation number 5. So using equation number 5, we can determine the fugacity. And here we have an integral alpha into dp. The value of that integral can be evaluated by plotting alpha against pressure and then finding the area under the curve starting from the pressure 0 to the required pressure. So by plotting this graph alpha, integral alpha dp, and that will give by plotting alpha against pressure we get a graph, and from that graph we have to find the area under that curve starting from the pressure 0 to the required pressure. So if we know the value of that integral, we can easily calculate lnf, or we can easily calculate the fugacity. So this is about the determination of fugacity